Solving a quadratic inequality. Graph the solution to the following inequality on the number line. X squared minus 10x less than or equal to negative 24. The way we want to approach this is almost pretend it's an equation. And so we're going to go ahead and balance the inequality. Let's add 24. And what do we have now? X squared minus 10x plus 24 is less than or equal to 0. So we have an equivalent inequality. Now we're going to react to this by factoring. I use trial and check. So 6 and 4 are factors that will multiply to get you 24, and then apply the signs. So outside I'm going to subtract 4x, and then inside I'm going to subtract another 6x. And I've checked this. And the last position is negative 6 times negative 4, and that, of course, equals to positive 24. Once again, our inequality is what? Less than or equal to 0. What does this mean? Well, this means we're going to test around your x-intercepts. Test around your x-intercepts on a number line. Let's try this again here. And you don't have to draw this perfectly to scale or anything, but you do need to put negative 6 here. And then, I'm sorry, not negative 6. That should be a 4. This should be a 4 here, and then this should be a 6. And so we're going to test around the x-intercepts on the x number line. You could even call 4 and 6 are the zeros of your quadratic function. And which quadratic function are we talking about? We're talking about this one right here. So the zeros of x squared minus 10x plus 24 is 4 and 6. We're going to test around it, and we're going to see if we pick, let's say, test x equals 0, what we want to do is test the original inequality, or we could test it here. We could test it at, what, 0 minus 6, 0 minus 4. Is this, in fact, less than or equal to 0? And the answer is 24. Is 24 less than or equal to 0? And that is false. That is bogus. So if it's false, if it gives you a false inequality, that means we do not shade that part of the number line. Let's test x equals 5. If we test, let's say, x equals 5, we get what? We get negative 1, and then we get positive 1. Is that less than or equal to 0? Is negative 1 less than or equal to 0? That is true. And so if it's true, we do shade that. Okay? So far we have a false here, a true here, and one more test. What should we test now? Something after 6. Sometimes it's easier to pick something gigantic, like test x equals 100, because that's in the domain of the quadratic function. So if test equals 100, you notice that it's what? It is 94 times 96. Well, obviously, that's positive. And if you write this, is this positive number less than or equal to 0? It's a positive number greater than 0. Is it less than or equal to 0? That's, once again, bogus. That is false. And so if it's false, we don't shade that at all either. Now, because of the less than or equal sign, because of this right here, that symbol right there, you got to remember the shade. X equals 4, that's 0, and then we also have the shade another 0. We have the shade x equals 6. So I'm going to go back and shade now. We're going to shade the 4, I'm going to fill in that dot. We're going to shade every x value in between because that would yield a true inequality. And then we have to shade the 6. Our final answer is what? We could write our final answer in interval notation. Simply matches your graph. 4, 6, and then bracket. Order matters here, so it's bracket, 4, 6, bracket. Yeah, you're reading this from left to right on the number line.